Welcome to Curie Electronics. This is the second part of HSFC Technician-B Electronics exam question paper. And this exam was conducted on 13th March 2022. So first 30 questions we have solved. So let's solve the remaining questions. Question number 31. An asynchronous 4-bit binary down counter changes from count 2 to count 3. How many transitional states are required? This question I feel it is wrong because it's saying a down counter. Also, count is changing from 2 to 3. For a down counter, 2 to 3 change is not possible. It should change from 3 to 2. So, anyway, I will take it as an up counter. It is changing from 2 to 3. Then what is the case? So 2, we have it's a 4-bit counter. So 0, 0, 1, 0. This is a 2. And if it is counting up to 3, then it is 0, 0, 1, 1, 3. Now if we see how many states we have changed here, actually these all are same only. There is no change for these three bits. Only the last one has changed. So if that is the case, if it is an up counter, then the answer is going to be 1 because only one state has changed. That is option A. But I really feel this question, I think they may omit it. They may remove from the list because it's given as a down counter and counter changes from 2 to 3. For a down counter, that is not possible. So let's move to the next question. A unit impulse function has see, this is the time axis, time, and this is y-axis is the amplitude. Then a unit impulse pulse will have a large value. Unit impulse pulse will have a large value. Okay, large value. But pulse width equal to 0. Pulse width equal to 0. So if we see the options, minimum pulse width, it can't have minimum pulse width. Pulse width has to be 0. Then all of the above also we can neglect. Then there is large amplitude, unity weight. We can go with a large amplitude. That is the impulse function, large amplitude. Question number 33. The load cell is used for the measurement of force. Now you may think, why not mass? See, this load cell, we use it in weighing scale. There we are measuring weight, that is mass into, we are measuring weight actually there. W equal to mass into acceleration due to gravity, but we are not measuring the mass. So the right answer is force. Question number 34. What is the value of current I? This is based on Kirchhoff current law. If we see this, let's apply the Kirchhoff current law here. That means what at a junction, incoming current equal to outgoing current. That is what the KCL states. So this I is the incoming current, 2 amps outgoing current, 3 amps incoming current, 4 amps outgoing current, and 5 amps outgoing current. Now we'll write incoming currents. That is I plus 3 amps. That is the incoming current. Which are the outgoing currents? 2 amps plus 4 amps. 2 amps, okay. 4 amps plus 5 amps. So I plus 3 amps equals 2 plus 4, 6, 11 amps. So I equal to what? 11 amps minus 3 amps. So we'll get 8 amps. So 8 amp is the right answer. Option B is the right answer. Which of the following is the odd one out? Ceramic capacitor, electrolytic capacitor, paper capacitor. But tuning capacitor is completely a different thing. There is a movable arm. We can move the plates of this tuning capacitor by using the shaft attached to it. So tuning capacitor is the odd one. In a series circuit, which of the parameters remain constant across all the circuit elements such as capacitor, resistor and inductor? The answer is option B. In a series circuit, current is same throughout the circuit loop. What about in a parallel circuit? Voltage is same. What does the circuit in the figure represent? It is not a clipper, it is a clamper circuit. This clamper circuit is clamper. This is also known as DC restorer circuit. Let's go to the next question. Question number 38. Assuming the diode in the circuit is silicon diode. Okay, so see silicon diode. That means there is going to be a voltage drop of 0.7 volt across the diode. What is the current in the given circuit? Now we have a voltage source that is 5 volt. Then one resistor is there, that is 1 kilo ohm. Diode is there. Okay. So this diode we can replace by a voltage source. That is because 0.7 volt is going to drop. Polarity is cathode is going to be the positive. Not cathode. Diode anode is the positive one. Okay. The diode anode positive. So here is plus minus 0.7 volt. Now if we apply the KVL, we can find what is the current through the circuit. So to make it simpler, we need not to apply the KVL. What you have to write? I equal to what? The resistor is connected between two voltage sources, that is 5 volt and 7.7 volt. So 5 minus 0.7 upon 1, you will get 4.3 milliamps. See, I didn't bother about the units. Why? See, whenever I solve this kind of problems, V in voltage in volts only I will take. Resistance always I will take it in kilo ohm. Then finally my answer I is going to be in milliamps. This I will stick to this unit system so that I need not to worry about the units. For a given transformer, turns ratio is equal to N. What will be the impedance of primary with respect to secondary? So NP upon, that's the number of turns of primary upon number of turns of secondary square equal to, it relates the impedance of primary upon impedance of secondary. So this we can write it as N square equal to ZP upon ZS. So now what is the question? For a given transformer, turns ratio is equal to N. What will be the impedance of primary with respect to secondary? With respect to secondary we have to write. So ZP is going to be impedance of primary is going to be N square ZS. That is the N square ZS. So the right answer is N square times the secondary impedance. Option A is the right answer. The capacity of a battery is measured in ampere hour. What is the unit for measuring footprints in PCB? That is mil. We use for the PCB design, the track length, the holes, all we use mil. Then what is 1 mil? 1 mil equals, all of you know what is 1 inch? 1 inch upon 1000. This is what? 1 mil. 1000th of an inch is known as 1 mil. So next question. A 4-bit ripple counter consists of flip-flops, which has a propagation delay from clock to Q of 15 nanoseconds. Q means output. Clock, once you apply clock, will get output after 15 nanoseconds. What is the total time taken for the counter to recycle from 11 to 00? Now, a 4-bit counter will start from counting from 000 to 0001 to it goes up to 111. After 11, what it comes? It should go back to 00. That is what he is telling in the question. And he is also telling it's a 4-bit ripple counter. Ripple counter means what? Here we are applying the clock. This is a clock. Then this output. These are flip-flops, okay? Flip-flops, 1, 2, like that. 4 flip-flops are there. 4 flip-flops are there. So this output will be driving the clock of the next flip-flop. This is a clock. Again, this output will be driving the clock of the next flip-flop. This continues. That is why this is called a ripple counter. In a ripple counter, the delay gets added up. So each is having 50 nanoseconds. 15 nanosecond. If you see, all the state has to be changed from 0 to 1. And now all the 1 to 0. So all this delay will get added up. So the answer is going to be 60 nanoseconds. 60 nanoseconds. Question number 43. A carrier is simultaneously modulated by 2 sine waves having modulation indices of 0.6 and 0.4. What is the total modulation index? Now this total modulation index m equal to square root of m1 square plus m2 square. m2 square. Let's put the values. That is, what is m1? That is 0.6 whole square plus 0.4 whole square. Square root of, what is 0.6 square? That is square of 6 equal to 36. So after point we should have the 0.36, 36. So similarly it is 0.16. Now if we add these two, what we get? 0.52. And now we don't have a calculator. So what I will do? I will multiply and divide the numerator by 100. Okay. And now what is there? This 52 perfect square I don't know. But what I will do? I will take a nearest number 49 upon 100. Now I will take the square root, that is 7 upon 10. I will get 0.7. So I will see which is the closest value. That is the option C is the right answer. Option C is the right answer. Electromagnetic wave transport charge, current, electric field, energy. The electromagnetic waves transport energy, or we can say electromagnetic field, not electric field, not electric field. Electric field as well as magnetic field will be there. So we can say it is energy. standard open circuit voltage for lead acid battery at standard condition is? It is 2.048. When you have only one cell, we can call it as a battery also. If you are making the battery with one cell, then it is we are making the battery with one cell, then it is a battery. So standard it is 2.048 for the lead acid battery. Question number 46. Voltage across 5 ohm resistor. So this is the 5 ohm resistor here. Here we have the 5 ohm resistor. Now, if the voltage across all these components are same, so what we will do, we will apply nodal equation here. This node I will consider as a node, and the voltage at that point is V. And now what is there? And now this also node only. This I will take it as a reference node, that is 0 volt. If this 10 amp is coming into the node and 5 amps is going out of the node. So now what I will do, I will take all the remaining currents as coming into the node. No, I will take it coming out of the node, because that I am taking the reference node I have taken as 0 volt. Anyway, you can take it, nothing wrong. So I will take all currents are flowing towards the, not here, that is not there, that is the current source, towards the reference point. Now all outgoing currents, positive, incoming negative, I will take it. To the node, incoming negative. Now if I now I'll write the equation, nodal equation for this network shown. This 10 ohm resistor is connected between V at that V voltage V and the 0 volt. So I will write what is the current flowing through 10 ohm resistor. I will write it as V minus 0 upon 10 ohm plus, next also similarly V minus 0 upon, I am taking plus, these currents are going away from the node, whichever node we are considered, divided by 5. And the other one is incoming current. I will take it as negative, that is minus 10. Next is the outgoing current, that is V upon 2. Next also outgoing current, that is V upon 1. 1 ohm, I am writing 1 only. Next is the outgoing current, so it is plus 5 equal to 0. Now we can simplify V upon 10 plus V upon 5. Next I will write V plus 2 term, V upon 2. V upon 2, then V. Now what I will do, these two I will add it up. Minus 10, if you add with plus 5, then we will get minus 5 equal to 0. Now actually I want to take the LCM. Instead of that, what I will do, multiply the entire equation by 10. Then what I will get, a V plus 2V plus 5V plus 10V, my 5 multiplied by 10, 50 equals 0. 0 multiplied by 10, 0. And now we can add V plus 2V, 3V, 3V plus 5V, 8V, 8V plus 10V, 18V. 18V equal to 50. Now what is V? V equal to 50 upon 18. If you simply assume whichever the value matches, it is going to be 2.83. It is coming around 2.83. So the right answer is option B is the right answer. Option B is the right answer. Let's go to the next question. Question number 47. In digital storage oscilloscope, the analog signal is digitized using one of the following. Analog signal, how do you convert to digital? Using an analog to digital converter. Analog to digital converter. Question number 48. Which of the following electrical characteristic is not inhibited by an ideal op-amp? Not inhibited, okay, not inhibited. The right answer is infinite output resistance. The output resistance is going to be ideally 0. Output resistance is going to be ideally 0. Question number 49. In which region of operation does a transistor act as an open switch? It is the cutoff region. In the previous many videos, we have seen these questions. In which region of operation does transistor act as an open switch? It's a cutoff. Cutoff means transistor is off. Transistor off means what? In cutoff, what is it? What is happening? In cutoff, emitter base junction. What it is? It is reverse biased. Collector base junction, reverse bias. Both the junctions are reverse biased in cutoff. Question number 50. A counter circuit is usually consist of. Counter, how do you make counter? Using the flip-flops connected in cascade. Option C is the right answer. We have seen the one previous question. The basic building block of arithmetic unit in a digital computer is. What is the basic unit of ALU? Let's try to make a guess. It is not going to be the comparator. It is not going to be the multiplexer also. We don't do subtraction in electronic digital. What do? We'll take the complement and add it. And this also not possible. And the next this is the right option is adder. There is called carry look ahead adder, look carry ahead adder. Some adders are there. So the right option is carry a look ahead Harry, something like that is there. That is adders. The basic block of arithmetic unit in digital computer is adder. Question number 52. Now, if I look at the circuit, clearly I can see there are two AND gates, and that output is connected to OR gate. Now I'll try to redraw the circuit. Two AND gates are there. Then we have a OR gate. OR gate. And A and B are the input. For the top, we have connected a inverter. So for the top AND gate is going to be A bar, that is we can write it as A complement. So input is going to be A complement. Output is both the inputs are complemented. And for the this here, see, directly it is going to the AND gate, both inputs. So to the next AND gate, we are getting A and B. Now what is the output here? The above AND gate, that is A complement, B complement. The below AND gate, it is AB. If you give to OR gate X, then X equal to what? X equal to A bar, B bar, or AB. Which any option is there like similar? Okay, we have option D is the right answer. X equal to A bar, B bar, or AB. Question number 53. For a diode, reverse saturation current increases with temperature. For a single sideband signal contains 4 kilowatt. The power content at the carrier frequency is. See here, this single side means it can be upper sideband or lower sideband. So total power in SSB single sideband transmission equal to power of upper sideband, or it can be lower sideband, upper sideband. Then the answer is going to be 4 kilowatt only. A single sideband signal contains 4 kilowatt. The power conducted, the carrier frequency is, it is going to be 4 kilowatt only, because total power in the SSB equal to power of either upper sideband or lower sideband. Question number 55. Transformer utilization factor of a center tapped full wave rectifier is equal to, it is 0.693. Is the, for a half wave rectifier it is 28%, 28.8% for a half wave rectifier. For center tap full wave rectifier it is 69.3% for a center tap, and for a bridge rectifier full wave bridge, for a full wave bridge it is 81%. It is 81%. So the right answer is 0.693 is the right answer. Question number 56. Which of the following retains information once the power to the computer is turned off? ROM. It is, answer is ROM, read-only memory. It's a non-volatile memory. Power is off also, it will retain the memory, retain whatever it is stored. Non-volatile memory. Non-volatile memory. Non-volatile memory. And the RAM is known as the volatile memory. Volatile memory. That means if we power off, we are going to lose the data when the power goes. Volatile memory. Volatile. Let me write it properly. Let me write once more. So RAM is known as the volatile memory. Volatile. Volatile. T-I-L-E. So here in volatile memory, what happens? Once you power off, we are going to lose the data. Non-volatile memory, it is going to, the power of falls also, it is going to keep the data, whatever stored. Question number 58. 57. Question number 57 I have missed. I will add it in the last. Question number 58. In a hexadecimal number system, D stands for. In a hexadecimal, 16 numbers should be there. In a hexadecimal system, 16 numbers. Okay, in 16 numbers, that means how it is? It is from 0 to 9. Then instead of 10, A comes. So A is 10. B comes for 11. And C comes for 12. D comes for 13. And E comes for 14. F comes for 15. F has to be 15. So it is 0 to 15. 0 to 15, 15 numbers are, 16 numbers are there. 15. So here what is the question? In a hexadecimal number system, D stands for. D stands for D, 13. 13 is the right answer. 13. Question number 59. Which of the following is the most common unshielded twisted pair connector? This RG58, RG59, these are the coaxial cable ones. Coaxial. RG58 and RG59. And this RJ11 is used for telephone. And this RJ45 used for Ethernet. Ethernet. Nowadays, you know, everybody is having computer and internet connection or LAN. So RJ45 is the more popular one, most common one, RJ45, which is used for the Ethernet. It's an 8-pin connector. Question number 60. Nickel cadmium, Na cadmium battery is more preferred than lead acid battery in military applications because it is because it can be easily charged and discharged. Can be charged and discharged. You may have some doubt why all of the above also. It can be all of the above because this option is coming. Deliver less amount of power. That is not correct. It should deliver in defense equipments and all. It should deliver high amount of power in short duration. So it can be easily in the charging and recharging cycle is many number of cycles. It can be charged and discharged. So the right answer is can be easily charged and discharged. We have completed what one question I have missed out. I will add it up. Okay, here I will add that question. Yeah, this was the question I have missed. That is question number 57. TCP/IP. TCP stands for, all of you know, Transmission Control Protocol. Transmission Control Protocol. That is the answer. With this, we have completed all the questions. This question was really a reasonably good question paper, so that ISRO gets good talent. But I think they asked some few questions from the diploma also. So if you like the videos, please share with your friends and don't forget to hit the like button. Thanks for watching.